Welcome to Brunda Engineering Academy. Our channel completely deals about the gate and ECET patterns. So, in this video, we have to discuss about the fundamentals in the thermodynamics subject. Fundamentals in the thermodynamics subject. Thermodynamics. To know, to learn about the thermodynamics, first of all, you should know the basics. So in this video, we have to concentrate on the laws of perfect gas. In the ECET point of view, in the gate point of view, these is the basic fundamentals of thermodynamics. First of all, let us discuss about perfect gas. Perfect gas means the gas which obeys all the gas laws. The gas which obeys all the gas laws. Okay, all the gas laws under all conditions of pressure and temperature. Okay, at all conditions of pressure and temperature, that gas will obeys. Obeys means the satisfies. If that satisfies the all the conditions, that is called as the perfect gas. In this topic, we discuss about the three terms. One is the pressure, another one pressure, volume, temperature. Pressure, volume, temperature. Pressure, volume, temperature. Volume is represented by capital V, temperature represented by capital T. So here the gas which obeys all the gas laws under all conditions of pressure and temperature is called perfect gas. And one more concept is in perfect gas molecular attraction between the atoms will be zero. That means there is no attraction between the molecules in the gas. That is the perfect gas. So now the first law is Boyle's law. The first law is Boyle's law. Now the statement. That means suppose if you consider a gas of a cylinder, it is a gas, it is a gas, it is a gas container. So for this system, at constant temperature, that means the temperature is constant, temperature is kept constant. Suppose if you maintain a temperature of 273 degrees, suppose 300 Kelvin, 300 Kelvin. So that means this is the fixed and the volume is inversely proportional to the pressure of the gas. If at constant temperature, Boyle's law statement is at constant temperature, volume is inversely proportional to pressure of that gas. Okay, then what will happen? To eliminate that proportionality, we can write it as PV equal to constant. Then it can be written as P1 V1 equal to P2, P1 V1 equal to P2 V2, P1 V1 equal to P2 V2, like this. The statement of the Boyle's law is at constant temperature, volume is inversely proportional to the pressure of gas. Volume is inversely proportional to pressure of the gas. Then PV equal to constant, and it is an important relation to solve the problems. P1 V1 equal to P2 V2. Okay. Next law is Charles law. Let us discuss about the Charles law. At constant pressure, here in the previous case, Boyle's law, temperature is constant. Whereas in the Charles law, the pressure is kept constant. Volume is directly proportional to the temperature of the gas. Volume is directly proportional to the temperature of the gas. Then it can be written as V by T equal to constant. V by T equal to constant. It can be written as V1 by T1 equal to V2 by T2. V1 by T1 equal to V2 by T2. That means 1 and 2 means initial condition and final condition. In the competitive examination point of view, at Charles law is at constant pressure, volume is directly proportional to temperature of the gas. The relation is V1 by T1 equal to V2 by T2. Next, coming to another law, that is Gaylaussac law. In the Gaylaussac law, the volume is kept constant. Pressure is proportional to temperature. Then P by T equal to constant. P by T equal to constant. It will becomes P1 by T1 equal to P2 by T2. P1 by T1 equal to P2 by T2. So it is the Gaylaussac law. In the Boyle's law, temperature is constant. Temperature is constant, whereas in the Charles law, that pressure is constant. In the Gaylaussac law, the volume is constant. Volume of the gas will be kept constant. Okay. Next, coming to one more, equation of perfect gas. Equation of perfect gas. It is a very important in thermodynamics point of view. Or it is also called as characteristic gas equation. Characteristic gas equation. The characteristic gas equation is PV equal to MRT. PV equal to MRT, where P is the pressure, V is the volume of the gas, M is mass of the gas, and R is the characteristic gas constant. Characteristic gas constant. Characteristic gas constant having the units of Newton meter per kilojoule Kelvin, Newton meter per kilojoule Kelvin, or joule per kg Kelvin. Newton meter per kg Kelvin or joule per kg Kelvin. Okay, here one more observation. 1 joule equal to 1 Newton per 1 Newton meter. 1 Newton meter. Okay. Now characteristic gas equation PV equal to mRT. It can be simply written as, here it is the volume. It is the volume. We can written as PV by small m equal to RT. V by M means volume by mass. Volume by mass equal to specific volume. Equal to specific volume. That means that small v is nothing but the specific volume. Specific volume is the ratio of volume to mass. Volume to mass. So we can write this expression as P specific volume equal to RT. PV equal to RT. And here for air, generally the gas can be taken as here air. For the characteristic gas constant of air, characteristic gas constant of air is 0.287 kilojoule per kg Kelvin. 0.287 kilojoule per kg Kelvin. While solving the problems, this will be important. Okay. So next are 287 joule per kg Kelvin. Characteristic gas constant of air is 0.287 kilojoule per kg Kelvin or 287 joule per kg Kelvin. 287 joule per kg Kelvin. So it is about the characteristic gas equation. Here the important is equation PV equal to MRT. This can be used in the solving of the problems. Okay, the problems can be discussed in the next video. Here characteristic gas constant units are Newton meter per kg Kelvin or joule per kg Kelvin. Characteristic gas constant value is 0.287 kilojoule per kg Kelvin or 287 joule per kg Kelvin. 287 joule per. Next is one concept. Suppose if you consider a gas of volume V, a gas of volume V. Okay, in that volume, how many number of moles? How many number of moles presented in a gas? How can you calculate? Number of moles in a gas can be calculated by the ratio of mass of the gas. It's mass of the gas and molecular weight of the gas. Mass of the gas and molecular weight of the gas. The ratio of mass of the gas and molecular weight of the gas can be calculated for the number of moles in a gas. And one more thing is universal gas constant. Previously we taken at characteristic gas constant, whereas this is universal gas constant, that is represented by Ru. Universal gas constant is the product of the characteristic gas constant and molecular weight. Universal gas constant is the product of the characteristic gas constant and molecular weight. This can be simply written as Ru equal to R into M, where Ru is the universal gas constant and R is the characteristic gas constant and M is the molecular weight. M is the molecular weight. Here the one more important bit is Ru, universal gas constant value is 8.314 kilojoule per kg mole Kelvin. Kilojoule per kilomole Kelvin. Kilojoule per kilomole Kelvin. Whereas 8314 joule per kilomole Kelvin in terms of the kilojoules and in terms of the joules. Okay. So these are the some important concept in the laws of perfect gas. In the next video, we will discuss about the remaining gas laws also. So please subscribe Brunda Engineering Academy channel. Thank you.